Now let's look at page 8, problem number 10. So, a data entry manager wishing to estimate the average number of errors an employee makes per hour of work does a study. She will call this unknown parameter lambda. I usually call it theta, but here we said it's lambda. As data, she will randomly select 3 1-hour periods and will count the number of errors made. Thus, her data will consist of 3 counts, which she will call Y1, Y2, and Y3. Since she assumes errors are rare, she models the data using a Poisson distribution, which means the probability of yi equal to yi, where yi can be a value 0, 1, and so forth, follows a Poisson distribution. And from our table, the probability of x is lambda to the x times e to the minus lambda over x factorial. So in our case, we called it yi instead. So it's going to be lambda to the yi times e to the minus lambda over yi factorial for one observation. Now we want to find the maximum likelihood estimate for lambda, which means we want to look at the likelihood function for lambda, which is the probability of the data y1, y2, y3, given we knew what lambda was. Well, in this particular case, since they were IID, it's the product I from 1 to 3 of lambda to the yi over yi factorial times e to the minus lambda. Now, what do I mean by that? If they're IID, they're independent, so the joint distribution here is just the product of the marginals for each, and the marginals for each we had just written down earlier. That is the strategy I use. I usually write down the probability of observing one data point and then expand it to the probability of observing all of the data. So this becomes, well, this is like lambda to the y1 over y1 factorial, e to the minus lambda times lambda to the y2 over y2 factorial times e to the minus lambda times lambda to the y3 over y3 factorial times e to the minus lambda. This is actually just lambda to the y1 plus y2 plus y3 divided by y1 factorial times y2 factorial times y3 factorial times e to the minus 3 lambda. So that's the likelihood function. Usually I ignore this denominator because it is not a function of lambda, and if I'm trying to find the lambda that maximizes this doesn't add any value at all. So however, instead of maximizing the likelihood, I maximize the log of the likelihood. So I take the log of this, and the log of this piece of it is just a constant, and I don't care, so I'll just write it C. Plus the log of this factor is y1 plus y2 plus y3 times the log of lambda, and the log of this piece is minus 3 lambda. And so what I have here is, that's the log of the likelihood. I want to find the lambda that maximizes this, so I'm going to take the derivative of the log of the likelihood with respect to lambda, and I'll get 0 plus y1 plus y2 plus y3 times the derivative of the log of lambda, which is 1 over lambda, minus 3 times the derivative of lambda, which is 1, so it's minus 3. I set it equal to 0 and solve for lambda. I'm going to multiply through by lambda. Add 3 lambda to both sides. Divide by 3. And I'll get y1 plus y2 plus y3 divided by 3, which is what we call the mean. And so I think this is my maximum likelihood estimator. I'm not sure it really is a maximum, though. So I really should look at the second derivative of the log of the likelihood function with respect to lambda. But the derivative of this is going to be, this is the same thing as this sum times lambda to the negative first power. So it's going to be minus 1 times the sum times lambda to the negative second power minus 0, because the derivative of a constant is 0. And anyway, if I look at this, these should be greater than 0. If they're 0, I'm going to have a problem. But as long as this sum is greater than 0, this is always going to be positive because it's something squared. And I have a negative number here. So this second derivative would always be less than 0 unless the sums of the observations are equal to 0. Then we would have trouble. But as long as it's less than 0, it's opening downward, and I do have a maximum likelihood estimate. Notice when we were looking at one of our examples of what's the probability of complaint the next month, the trouble was we didn't have any complaints, and so it was not a maximum likelihood estimate per se, because it didn't maximize the likelihood, because it failed because, oops, it didn't make sense. So this is page 8.